Welcome, YouTube. Welcome, SHSATers. All right, so we're on the 2022-2023 SHSAT Handbook. We've done all Form A math. We've done all Form B math. We did the poems for each of them respectively, and we're going to start doing the grid-ins. I might split this in two. I'm actually thinking live how to progress through them because there are certain topics, but I think I might just do it sequentially. So let's jump into it. Before I start, just make sure you guys are aware of how to do grid-in on the grid-in. So the handbook has a section, maybe 5 pages or so on describing it, as well as these directions. And I believe there's directions on the actual exam itself. Go through all of that and make sure you're clear what to do. I work with students, and every year, a small handful I'll notice, because at one point we started actually using bubble sheets. I noticed that they're not filling in the stuff correctly, and they're not doing the alignments, and they're leaving out information, and they're skipping zeros and things like that. So it's important to get those right because you don't want to get the 5 grid-in questions correct and then grid them in wrong and then be marked wrong for it. And that's your last shot at it. You don't get a second attempt. The only thing that matters is your Scantron sheet, and that is that. So definitely go through the pages in the SHSAT handbook that's dealing with how to do those things. All right. The second kind of logistical thing I want to mention is they're not giving much space in this section. I think if it was in the Form A and Form B proper, they would probably give a little more space. That said, some of these are succinct and clear and concise, and they don't necessarily need extra space. That said, a question I get often is, uh, can I bring scrap paper? No, you can't bring scrap paper, but the DOE will provide scrap paper to you, and you can ask for more if you need it. They will collect it at the end, just like anything whatever you go into the test with, that's put on your desk or whatever, you're not allowed to use, and anything they give you, they collect back. So basically, you're going to walk in with pencils and erasers, and you're going to leave with pencils and erasers. Anything relating to the exam, the questions, your scrap paper, your actual test booklet, they will collect, okay? All right, so let's jump into here. Carol's Alterations Company charges each customer $5 per item plus $3 for supplies, okay? Carol charges a customer more than $50. What is the minimum number of items Carol altered for the customer? Okay, so this is kind of ish a y equals mx plus b. I'll put that on the top basically. It's involving a linear kind of thing, but it's this more than 50 that gets the gotcha. So it basically comes in inequality. So if we have $5 per item, I'll call that I, right? Plus $3 as kind of a flat fee she's charging for supplies, right? Um, and she wants to charge more than $50. So that's what we have there. 50 is an amount, a dollar amount. $5 is an amount times I, the number of items, plus and $3 is an amount as well. So we can see that this does make sense. So what we're trying to figure out is what is the least number of items I that she needs to do. Well, let's subtract 3 from both sides. So we get 5I is greater than 47. And then if we divide both sides by 5, that goes away, and that becomes that, okay? So we have 9 times 5 is 45, right? And we have 2 left over, all right? So if it's 9, right? If let's say you think the answer is 9, because it says minimum here. If you think it's 9 and we run it through the equation or through the English, we're going to get 45 plus 3 is 48. That's not greater than that. So right there, we know it needs to be 10. So 10 is the answer you would grid in, right? What is the minimum number of items that she needs to be where it's more than 50, right? And and the answer, by the way, So 9 and 2/5 is 9.4, right? Because this is equal to 4/10, right? This is not the answer. 9.4 is not the answer, because she needs to give a full altered item to the person. We're not dealing with partial items here. All right. So that's 10. So this basically dealt with doing an inequality based on the equation of a line. That's the underlying concept and topic going on there. And again, we can feed the 10 back in. If there's 10 items and the $5 an item, that's $50 plus the 3, 53. So 53 is the least number where we break over 50. All right, so that makes sense. We ran it through. We did a sanity check. You know, yeah, that's the way to do it. You could wild guess the answer here. You know, you could start with 100 and see it's too large. You can go down to 5 and see it's too small, and you can whittle that back and forth. But that's you should be thinking algebraically at this point, and you should be able to addressing these questions. Okay. Question number 2. Point N is directly above point M. So I'm basically just going to draw that. I have point N. It's directly above M. I'm not sure how much space to give this here. Okay. Point M is 8 feet below the ground. So this is what I'm going to do. I'm gonna drag that down slightly. I'm gonna put M over here because I want to make sure we have the thing here. So this is going to be ground level. I'm just going to call that GL, right? And if we want, this is a number line on its side, or if you want, think of it as a thermometer. All right. So point N is directly above M. Cool. So we're here. Point M is 8 feet below the ground. So if this is 0, M is minus 8. Okay. And point N is 40 feet above the ground. So N is 40. So what they're asking is, what is the distance between the 2 points from, let me change the color here. And let me just check here that we're live and the screen is correct and all that stuff. Yes, it is. Okay. So what we're trying to find is the distance from here to here. Well, from 0 to here is 8, and from 0 above is 40. So we get 48. 48 is the answer. All right. It's not 32. It's not 40 plus that. What we're basically trying to do is get 40 plus the absolute value of minus 8, if you will. All right. We could have done it backwards. We could have done also minus 8 minus 40. That would give minus 48. Okay, that's also the distance. But normally when we're dealing with distance, we're dealing with positive numbers. So we would essentially get the absolute value of that minus 48 if we did it that way. All right, so this is just dealing with ranges of numbers and things like that. And the last one is this number 3 is append this. So there's a couple ways to do this. I'm noticing that the minus 2.8 and the minus 0.2 is minus 3, right? And then this minus and this minus gives us plus 1.2, and that becomes 1.8 minus. All right, that's just one way to do it. There's other ways to do it. We could have done, what could we have done here? We could have done the minus 2.8 and the minus 1.2 is plus 1.2, and that's going to be equal to minus 1.6. And then we have to add this back into there. So that's minus 0.2. And we also get minus 1.8 the same way. So we're trying to use alternate techniques on as many questions as we can, just to verify and double check. One of the problems with double checking something is if you did it wrong the first way, especially under the real test dynamics, you usually want to do it another way, because if you do it the same way, you're probably going to make the same mistake twice. So you certainly double checked it, but you made the same careless error or computational goof or whatever twice. So you normally want to avoid doing it the same way. And your double checking should be reversing operations and just using it different ways. Even if it's as simple as something like adding 1 plus 2 plus 3, you can get 3 plus 3 is 6. You can also do it backwards. 3 plus 2 is 5 plus 1 is 6. Always jazz it up. Always add the numbers up in different ways the second time through, just in case something gets here. Even though the SHSAT is not testing you on computational skills of this level, this is too naive. Attention to detail and all these other kind of things do matter. So, all right, let's go to number 4. So we have the cost of a commuter train is what's being discussed here. We have an x-axis that is by units of 1, but it's numbered. Every other box is numbered, and that's in dollars, cost in dollars. And the y-axis is also in units of 1, but numbered 2, 4, 6, 8, 10 as well. So each square is a unit square. It's not double. It's not anything else. And I'm just noticing there seems to be a line there. It goes through the origin. So that's 0, 0. I already have a heads up that this y might be a constant of proportionality question. I don't know. But I can kind of check that. What I like to look for is points where the line smacks where 2 lines intersect on the grid here. So that seems to be right here, okay, which is 5, 2. And it does it again up here, which is 10, 10, 4. Okay, so that does look like it's a constant of proportionality example. I don't necessarily care yet, so I'm more talking out loud here and giving you guys food for thought for what to kind of be thinking about and looking for. All right, so let's actually go to the words. So in any event, we have a cost versus uh, the number of stops of a train. So basically, if you look at it, as the number of stops goes up, the price goes up. As the price goes up, the number of stops goes up. Right? That does seem to be a proportional relationship, especially since this is a line and it starts from 0, 0. The 0, 0 is important because it means when you haven't gone anywhere, it shouldn't cost anything. And if it doesn't cost anything, you haven't gone anywhere, right? So that works out. So now that we've kind of bashed around the illustration, let's look at the words. So the graph shows the cost in dollars X, right? So we talked about that. The cost in dollars is X. For riding a commuter train through Y stops, so Y is the number of stops, and it told us that on the captions. What is the rate of change for this relationship? Expressed as a decimal. So the fact that they're actually asking us for a rate of change means there's a rate of change. If there was no rate of change, the question is invalid. Remember, this is not multiple choice. This is a grid, and they want a number. So this is confirming, this is coded language, that this is definitely a constant of proportionality question, okay? And for this relationship, this is a proportional relationship in particular, all right? So what is the rate of change expressed as a decimal? So this is our similar thing where basically the rate of change here is the slope. So we get the change in the y over the change in the x. That's the same as our rise over our run, okay? And we can basically pick any of the points here. If we label these, I'm going to call this O, this is point A, and this is point B. So at this point, that observation I made earlier, it has to kick in because to compute the rate of change, we need the point somewhere, okay? So one way to do that is to use the difference between B and A. So the change in the y for B is going to be 4 minus 2, right? And the bottom is going to be 10 minus 5, right? And that gives us 2 over 5, and that gives us 4 over 10. So we need to do this. We need to go further here because we need to grid it in. So we can have 0.4 or 0.4. You can grid in 0.4 or 0.4, right? Both are valid, and both will be accepted as the right answer. And just to continue on, I could have also picked between B and O. So B and O would have been 4 minus 0 over 10 minus 0, and that would have given us the 4/10 straight up. And I also could have picked between A and O, and that would have given us 2 minus 0 over 5 minus 0. So we're always getting that 2/5 or 4/10, no matter how we slice this, okay? Yeah, we could have also just counted. Let me change the color here. So again, we have all these different ways to get that 0.4 out of this. So if I just did those units, for argument's sake, using that one, I have 1, 2, 3, 4 by 10, right? So I have 4 over 10. That's how I do my slope. And it's a positive slope. We know that is leaning that way, even though this is a constant of proportionality, and it's not about necessarily a linear equation. It's about a proportional relationship, a proportional equation. We basically have y equals kx. Let me throw that up here. Okay, and k is the 0.4. So y is equal to 0.4 x, all right? And we can plug any of them in there. So if we plug in x being 10, which is this example here, we get 0.4 times 10, right? Which ends up giving us, if we follow this up and then go across, we get the 4. All right, so we were able to prove and double check and sanity check that all this is making sense and cool and awesome. All right, let me just check that we're okay again. Yeah, we seem to be. By the way, I normally have these go for an hour or something. I might do half an hour and then switch back and do a second stream perhaps. Okay. All right. So let's go to the next question. And if one of these is more complicated, I'll skip it and spin it out by itself. Okay. So this one again is the constant of proportionality. How do I know that? Because it says the table shows a proportional relationship. All right. I like to look at illustrations first to try to understand stuff. And then when I come back to the words in the question, it kind of fills it in what I thought. I find for me that works better because if I read the words, I'm not really going to dedicate as much attention to the illustration. So it's not like I'm spending 10 hours on the illustration. I'm just going to glance at it, try to grok what I can from it, and then let the words confirm that for me. The table shows a proportional relationship between the area of a floor uh, and the number of tiles needed to cover the floor. And I just said I was going to look at the illustration and I went to the words. Because it's proportional, all right, I know that I have the y equals kx relationship built in there. That means because they told us it was proportional, we know there's a k, all right? So what I might look at is just to see if I can grok the k straight up, all right? Because sometimes you can do that, especially once a table form. So I can see already that 80 times 6, right? 80 times 6 is 480, all right? I have 480, and 480 from 520 is 40. So I can see straight up that this is 6.5 times. I can't see that as easier by multiplying 130 by 6.5 or 220 by 6.5. But it appears to be that's the case, right? 480 plus 40 is 520. So that's K right there. And then they ask, what is the unit rate? Well, that's it. That's the answer already. The answer is 6.5. All right, so let's do this other ways. Let's do it the way we just did question number 4 to try to make sense out of that. Yeah, so what we can do is if we again use the change that it's the change in y over the change in x, right? So if we do it between these two, right, and if this is y and that's x, all right, we're going to get 315 divided by 50. Right, if it did that correctly. Wait a second, I did not. That should be 325 divided by 50. All right, so what I'm going to notice is 25 definitely goes into the top and 25 goes into the bottom. So I'm going to do 50 divided by 25 is 2, and 300 divided by 25, there's 12 of those, right? There's 4 25s per 100, so there must be 12 per 300, plus the 325 gives one more 25. All right, so we get 13 over 2, and that's equal to 6.5, right? So just like the other example, we can pick basically any 2 points. Let me use the space over here between these two. So we have, what do we have? We have 1430 minus 845. And if that's 900, we're going to get 430 plus 45 for 85. 585 over 70 over 90. Okay. If I divide both of those by 5, for the denominator, I get 1, I get 18, I believe, right? And the numerator is going to be 5 goes into there 1, 5 goes into here once, uh, with 1 left over, and it goes into there 113 times. Did I do that right? 585 divided by 5. No, I didn't do that right because the carry is 11137. So it's 117 over 18. So this one gets uglier. I noticed that both of those numbers are divisible by 3. In fact, I noticed they're divisible by 7. I mean, sorry, 9. So I have 113 over 18. And I chose the 9 because the bottom is, I know the answer already. I know the answer is already 13 over 2. So I'm going to divide by 9. I get 2 here. I divide by 9 into 11 is once, right? Wait a second, I wrote, and then we get 13 for there as well. I wrote 113. This is the wrong number right there. It should be 117. Right? Because we're going to get 9 into 11 is 1 time, 3 left over. 9 into 27 is 3. So we get to 6.5 again. And again, we can pick any of the choices here. And I like the fact that I could get the answer immediately by using this one. So I normally scan for something like that and see if I can just straight up figure out what K is based on that. 80 and 520 were the easiest 2 numbers. I doubt I could do that. You know, I could do 6 times 220 and try to figure that out, but that just seems to be more uglier. Anyway, that's basically what they're doing. And now that we know what K is, we can feed it back in. So we're going to get Y is equal to either 6.2, 6.5x or 13 over 2x, right? All right, so we could plug our number in there, which is basically any of these choices here into the x, and we should get the y. All right, so if we used 80, we can get that into there, and we basically get 40 times 13. Before that would give us the 520 back. All right, so our double check is all there, and it works, and we live happily ever after. Yay! Okay. Okay, number 6 seems to be passed now. We're not going to talk about constant proportionality anymore. A train usually travels at an average rate of 45 miles per hour. It was scheduled to arrive in Bloomington in 8 hours. The train arrived 2 hours late. What was the average speed of the train in miles per hour? Mm. And by the way, this one's a little unfair. It should say for its return, right? For return. It's not the average speed over the whole thing from when it left to come back. All right, so there's a slight problem there. You should all be familiar with distance equals rate times time. All right, so what we want to do is use the 45 miles per hour and the 8 hours to find out how far away the train traveled from Bloomington to wherever the destination was. All right, under the normal conditions. So that would basically be 45 miles per 1 hour. And they're telling us it's going to be times 8 hours. Okay, the units would cancel here. So all we're left with now is miles. All right, so basically we have to do 45 times 8. 8 times 5 is 40, right? And 32, we get 360. All right, I can double check this because if it's 45 times 8, if I double the 45 and get 90, I'm going to half the 8 and get 4. And I'm going to do that again. I'm going to double this and get 180. And I'm going to half that and get 2. And I'm going to do it one more time, as basically 360 times 1. All right, so either way is fine. Sometimes you can do this in your head, although normally we're trying to avoid computations in the head unless they're totally obvious to us. You could have also just done the 90 times 4 at this point. At this point, that's easy enough to get the 360 on. All right, so there's multiple ways that we're sanity checking the 360 here. Okay, so it says the train arrived 2 hours late. So if we reapply the D equals RT, let me change the color of that to show that we're basically doing a step 2 here now. All right, so if we do the D equals RT again, we now know the distance is 360. Okay, the rate is what we're looking for. And the time, if it was 8 hours and it was 2 hours late, it took 10 hours. So we have R times 10, or it's equal to 10R, right? If we divide both sides by 10, we get 36. Is that new rate? And we're talking miles per hour. There was no unit conversion or anything like that going on here needed to necessarily happen. All right, and that's our answer. We could have avoided the computation to the 360, which because basically we have if we were to compare the two thingies here, we have the distance 1 equals the rate 1 times the time for 1, and basically we have a second one here, which is the second distance is equal to the rate 2 times time 2, right? And these are the going and the coming rates. But once we see that, we notice the distance is the same. In other words, D1 and D2 are the same. So basically what we're setting up is R1 T1 is equal to R2 T2. All right. Well, we have some of that information. All right. So basically we have the 45 miles per hour, right, times the time is going to be 8, and I should use an X there, times the 8, right, equals the other one, which is this here. We're looking for rate 2 times 10 hours, all right? So that means that if we divide everything by 10, and that was a multiplication sign here, right? This 10 goes away, so we have rate 2 equals 45 times 8 over 10. So I can cancel this out in various ways. I can divide 5 into here and get 2, divide 5 into here and get 9. And I have 2 here, and I'm going to make that 4, and I get R2 equals 36. All right, I could have done 45 times 8 again and divided by 10, the same thing we did above. I like to cancel out, and this is just the total another way to double check what we did without necessarily needing to do the 360 computation. All right, so it's another awesome way. And again, now we double checked by using a different technique. We sanity checked, and it just makes sense, and we live happily ever after. We can plug our R2 back in using any scenario here and make sure that our numbers plug out and work okay. All right. Give me 1 second here. How much time are we running here? We've gone half an hour, so we should be okay. I'm going to do a few more questions. And we might do this in one swoop. The next question is a doozy in a way, but so be it. All right, so we have an illustration. This is kind of a classic SHSAT question, if you will. And we're just going to beat on it. I see an illustration. I see 2 cylinders. I see a smaller one and a larger one. They give us the height of both, and they give us the radius of both. Almost always they're asking us to compare these two in some manner, or fit one in the other, or how many, if we fill the large one up, how many can we put in the smaller one, or vice versa. How many of the smaller ones can fit in the larger one, or whatever. So let's see what we have going on here. Just be clear and remember that this 4 and this 8 is the diameter of the bottom circle, right? The end, right? These are right cylinders, okay? So the figures above are cylinders. The smallest cylinder is completely filled with water. All right, so most likely we're going to have to figure out the volume here, okay? The larger cylinder is completely empty. All right, if the water from the smaller cylinder is poured into the larger cylinder without any water being spilled, to what height in inches will the larger cylinder be filled? So first of all, we always want to do heads up. Is there a unit conversion going on here? The answer is no, there doesn't seem to be. I have 4 inches, 6 inches, 8 inches, 12 inches. Height in inches is what they're asking us. So we probably do not need to do any sort of conversion. So the next thing we need to do is, do you know the formula for the volume of the cylinder? So this is the volume, this small, right? It's pi r squared times h. All right, so the volume, the small one is going to be pi. Okay, since this is the diameter here, the radius for this one is equal to 2. So we're going to get 2 squared. And then we're going to incorporate this 6 inches here. Don't do 0.5 for half of a foot or something. Everything is in inches. We don't need to do anything else with that. All right, so that's going to be times 6. And we're going to get pi times 4 times 6. And that's going to give us 24 pi. Okay, so the volume of the small cylinder is 24 pi. They're not asking how many of them will fit into there. So that becomes important because this 12 right here, let me change the color here for now that we're going to talk about the large one. We don't really care about this 12. It doesn't really come into play in this question. It didn't ask how many of the smaller ones could fill in there without it overflowing. It asked how much of the water from the small one can be poured into the large one without losing any drops. Okay, so that's a different story. So basically, we're going to kind of run through the same kind of scenario here, which is that the volume, the large one, it's also pi r squared h. Okay, and I said we don't care about the h, And in fact, that's what they're asking us to compute, right? Whatever the volume of this water here is in here, it's going to fill this up to a certain level. That's the height they're asking us for, right? If you ask the question, go to the end. What height in inches will the largest cylinder be filled? So they're asking how far does this hatched off water in here fill up into here, down there. And that's why we don't care about the 12. So what we need to do now is figure out the H in the volume of the large one. Not the 12-inch H, but the height of the water H. Okay? So we already know that the volume we're shooting for is this 24 pi. So that's what we're going to do. The volume, the large one, not of the whole cylinder, of only this part here with the new water in it, right? It started out empty and we're going to fill it up with water. The thing I'm filling in now, that's the height we're looking for. That's going to be the volume, the 24 pi, that we're going to throw into the large one. So we have 24 pi equals pi, and this, again, the radius of this is 4, all right? So we have 4 squared times h, all right? And that's going to give us 24 pi is equal to, if 4 squared is 16, we're going to get 16 pi h. And then to get h by itself, we're going to divide both sides by 16 pi. Okay? The 16 pi's cancel, so we have h equals 24 pi over 16 pi, right? 24 pi over 16 pi. Okay, the pi's cancel, and I can do 8 into the top, and that's equal to 3, and 8 into the bottom, that's equal to 2. So our answer is 3/2. Or we can grid in 1.5, right? Because these are grid-ins. All right, does that make sense? Right, so we don't care about the 12 on the larger one. All right, we don't care about the 12 on the larger one. All right, now if you notice what I did, it's almost similar to what I'm going to do for this number 6, because when we did this last thing at the bottom here, where did my tablet end up going? The thing I circled here, the G1 equals R1 T1, we can kind of do that same thing above. Because if we notice, the height of the larger one is double, and the diameter is also double. So we can also look at this and kind of play with it, if you will. So basically what we have is we're trying to compare the two volumes, if you will, between the two of them and try to make sense of it. So I'm just giving this as kind of a double checky way. So if we basically have pi times r squared of the smaller one, right? So I'm putting an r with a little s there, times the height of the smaller one, right? Okay, we want to make that equal to pi times r squared of the larger radius times the height. I'm going to write new because we're not using the 12. We're trying to compute the height. All right, so since we're trying to compute h new, if we divide both sides by pi r squared uppercase L, this cancels out, and then we come over here, right, and we do pi r squared L, right? The pi's cancel, and that's what we end up with. We end up with the r squared times the h over the r squared of the other one. Okay, and that ends up giving us the 3/2 when we plug those numbers in and do the same kind of a thing. So so if we actually do the r squared of the small, right, we get 2 squared, that's 4, and its height is 6, right? And then r squared of the large, that's 4, so we get that over 16. All right? And we get 24 over 16, And that's what we ended up with over here. Let me change the color of that to make that clear. That's what we got here. And it just becomes 3 over 2. So it's the same numbers, kind of doing it the same way, if you will. We could have also kind of looked at this also another way. And this one's kind of weakish, but if we basically compare the radius of the large to the radius of the small, right, we notice that there's a 4-to-1 ratio between the two of those, right? And if we're trying to get 6 inches, we can get x there. And the x there has to end up being 2 at that point. Sorry, it ends up being 4. And 6/4 is 3/2. All right, so yeah. So we beat this one around pretty well. That's number 7. Number 8, so I can't remember if it was Form A or Form B, but you also got a graph question. I think it was question number 99. I forget, again, I forget which form that stuff like that is involved with. So again, they're giving choices. Well, we have an R and a B. Those are our 2 choices. And we're getting 4 scenarios. There's 1 out of a 4 chance, conceptually, of getting the RR, the RB, the BR, and the BB. So that's the theoretical one. This one puts a spin on that because something else is happening. They're telling us what the probability is. We like to think we're flipping, say, a coin. Let's say red is heads and B is tails. And we have what we call like a fair coin or a fair dice, where we're playing a fair game. But what if the coin is weighted on a certain side, where you're in an amusement park and we know the games, or you're at a casino where the game is in the favor of the casino owner or whatever. So they might weight it to make the game more challenging or do something like that. You would argue that's deceptive, but you also are taking the risk knowing that it's deceptive. So if I had a perfectly weighted coin, then we could argue its theoretical probability was 50% head, 50% tail. But if there was something on it, like I stuck a piece of gum on one side, it's not going to flip around when I toss it the same way anymore. And it's probably going to land on the side where the gum is, more likely than the other side. Doesn't mean it's never going to land on the other side, but so I think this is kind of the scenario here. And remember, this is probability is not always about games of chance. There's just random probabilities and chaos theories and just different things based on how many people are at a mall at a certain time. All these kind of things like that. So let's go. A deck of cards has red cards and blue cards. Awesome. The probability of getting a red card in one draw, so that's the 0.7 they're talking about here. Okay, and if we notice, every red is 0.7. Okay, the probability of getting a blue card is 0.3. And we can see that here. That's 0.3. This is 0.3. This is 0.3. All right. The tree diagram shows the possible outcomes of drawing one card, putting it back, and drawing a second card. Okay. What is the probability, so we're down here, of choosing a red card and a blue card in 2 draws? All right. In either order. So that means we're going to pick, let me change the color this to fuchsia. We're going to pick a red followed by a blue to give, say, RB. Okay. The other thing we might do is pick a blue followed by a red to pick BR. We're not concerned about RR and RB. So they're out of our sights here, right? They're not the scenario that this is talking about. Okay. So we kind of need to consider kind of two levels of probability. The first is the probability of choosing in the top version, if you will, a red is 0.7, and then the probability of choosing a blue is 0.3. Okay, so that would be a red and a blue. So this is multiplication. So that would mean the probability of doing an RB is 0.21. Okay, and then if we follow that same logic here with the BR, the probability of pulling a B is 0.3, and so that's multiplication. Pulling an R is 0.7. This is also 0.21. So we have is 0.21 and 0.21, and it says either. So it's either RB or, right? Or is important. Either RB or BR. Well, or means addition. So in that case, we're going to add the 0.21 and the other 0.21 and get 0.42. Okay, and again, you can grid in 0.42 or 0.42. They're both fine. All right, and that's all that they're asking for here. So at one level, we're trying to interpret the graph. At the other level, in words, they told us about the probability here and the probability there. So we can even almost cover up the graph and not have to worry about it, because we know if there's only two cards, we can only get RR, RB, BR, or BB, right? And there's 1 out of 4. But remember, this got skewed by the 0.7 and the 0.3. So otherwise, it would have been 25%, and you would have gotten 50% as the answer. That's not what they're looking for here, because again, these are weighted not 50-50. They're weighted 0.7 versus 0.3. All right, so that's our deal there. And of course, it says give the answer as a decimal. There's no other really alternative for that. Okay, question number 9. Enid and Susie are playing a math game on a computer. A correct answer of a math problem is worth 3 points. So correct gets 3, and an incorrect is worth minus 2.5. All right, so that's basically our equation. We need to solve, how can I squeak this in here? So we have 3 times the number of incorrect plus minus 2.5. So really we could just do a minus there, because I don't really want to do a plus of a minus. Minus 2.5. Wait, give me a second here. I wrote incorrect there. That was correct. So you're going to get 3 points for correct minus 2.5 of an incorrect. Okay, and that's how we're going to figure out how many points they have. So we can just say something like the number of points is equals 3 times the number of correct minus 2 times the 0.5, the number of incorrect. All right, so let's see. Susie solves 6 problems correctly. So for the points for Susie is going to be 3 times 6 minus 2.5, and she gets 5 problems wrong, times 5. All right, so for her, she's going to have 18 minus 12.5. And that's going to give her 5.5. And I skipped Enid. So Enid, so the points for Enid is going to be, she solves 7 correctly. So it's going to be 3 times the 7 minus 2.5 times 2. So hers is going to be 21 minus 5. So her points is going to be 16. And then what we need to do is, because they're asking us how many more points does one have over the other, we're basically going to do 16 minus the 5.5. All right, and we're going to get 10.5. All right, and feed that back in and see if it's making sense. If you got an answer like 100, you know, just as a sanity check, that can't possibly make sense. If you got a negative answer, they're not asking you to do 5.5 minus 16. Technically, that's minus 10.5. This is just like the example, maybe question number 2 it was about the distance. It's not asking us to do something in reverse. We're normally taking the absolute value of things. So we're just trying to get a number like this. This is pretty straight up. There's not much anything else going on here. And finally, we're at question number 10. A basketball player makes 140 out of 200 free throws. Awesome, dude. The probability the basketball player makes the next free throw is X%. So what we're trying to do is take the theoretical probability, which is the 140 over the 200, and make it into a percent, because the next free throw is going to follow that same 140 out of a 200. I noticed that a percent is going to be 100, so I'm just going to divide the numerator by 2 and get 70, and divide the denominator by 2 and get 100. So this is equal to 70%. And they're asking us what's the value of x. It's going to be the 70. So the answer to here is not 0.70, it's not 0.7, it's 70, right? They're not asking us to do anything in a decimal form. It says it's in the form of X%, okay? If you wanted to, if you didn't see that observation of dividing both by 2, you could have divided this into like that, okay? And we would have gotten the same thing. 200 into 1, no. 200 into 14, no. 200 into 140, no. So we can put that and bring up the dot. 200 into 1400, yeah, that's 7. And we're done, right? We don't need to do anything else. We could have done the next one. We can throw in that 0 there as well if you want to. All right, and then we are finished the grid-ins. So the only thing left to do is the grade 9 math problems as well. I will probably throw in a random passage or two based on this feedback I got from my students over the past few months doing these examples. Some of them had gotchas on the ELA, particular reading comprehension I'm talking about. And I'll also review the Rev A, Rev B to see which ones may have had the most gotchas as well. And then we'll basically have done the cover-to-cover review at this point. Going through the passages live is hard because basically I either need to see that you read them on your own, or it's also good to see me ripping them apart and stuff like that as well. So it creates a whole bunch of it's too tedious. Even doing these are tedious. All right, guys, please like, please subscribe. As always, my email is at the bottom, GregsTutoringNYC @gmail.com. Hit me up, guys. Peace.